Hello, this is Algebra 1, Notes 9-2, Solving Quadratics by Graphing with Mrs. Moslick. Let's review first. So let's solve by factoring. So the first thing we do is look at this coefficient is 1. It is in standard form. The leading coefficient is 1, so it's a double bubble type of factoring, meaning I'll have two factors, each with an x. I'm looking for two numbers that multiply to get -3 and add to get 2. So factors of -3, -1 and 3, 1 and -3. Which pair adds to get 2? That would be -1 and 3. So we put -1 and +3. Now I have the zero product property. Two or more things equals 0. So either the first thing equals 0 or the second thing equals 0. We will solve, meaning I will add 1 to both sides, and I will subtract 3 from both sides, giving us our final answer, x equals 1 and x equals -3. Now, we will check this later in example 2. If you flip your page over to example 2, you will see that it is the same equation, but instead of solving by factoring, it'll be solving by graphing. Let's review factoring with problem number 2. First thing is it in standard form? Yes. Can I take out a greatest common factor? I actually can. I'm going to make sure that the leading coefficient is +1. So I'm going to take out -1. So factor out the -1. Basically, you have just the opposite of everything inside the parentheses. And inside the parentheses, we're going to be looking at, it is a trinomial, leading coefficient is 1. Therefore, it's a double bubble problem again, meaning we're looking for two numbers that multiply to get +12, add to get -8. So two numbers that multiply to get a positive and add to get a negative would be two negatives. So a -1 times -12 is, will multiply to get 12. -2 and -6 will multiply to get +12. And -3 and -4 multiply to get +12. The pair that adds to get our middle coefficient term, that -8, is -2 and -6. So we are done by factoring. Now we are going to solve by factoring. Set each factor equal to 0, -1 equals 0, x minus 2 equals 0, x minus 6 equals 0. Well, we know that -1 does not equal 0. We will find out later, meaning in section 9.1, what that -1 does to our graph. I will quickly tell you that -1 will actually put our parabola going downwards. But anyways, that's not a 0, and so now we'll add 2 to both sides, giving us with 2, add 6 to both sides, giving us 6. So we have two answers here, and we will check with example 3. Again, if you look at the back side of your notes, example 3 is the same equation. Instead of solving by factoring, it'll be solved by graphing. So let's go ahead and learn something new today. We're going to be solving we're going to solve quadratics by graphing. The steps are: make sure that the equation equals 0, make sure that the quadratic is in standard form. We're going to find the axis of symmetry, and the axis of symmetry is this equation right here, which is just our x term equals the -b/2a term. So to get that axis of symmetry, we're going to be making sure that it is in standard form. Then we're going to find the vertex from that axis of symmetry and then find 4 more points. So just in summary, a parabola has a vertex. It's either going to be going up or it's going to be going down. That a value, if it's positive, it'll go up. If a is negative, it'll go down. We'll learn more about that in 9.1. But the axis of symmetry helps us determine where the vertex is, because the axis of symmetry is a vertical line in a parabola of the form y equals ax squared plus bx plus c. And again, on that axis of symmetry is our vertex. Again, we'll get into that in these examples. So let's go ahead and do our first example. Find the zeros or solutions by graphing. So sometimes you'll be told find the zero of this parabola, find the roots of this parabola, or find the solutions. And so it just means the same thing. Where does it hit the x-axis, or in other words, if it equals 0, what are the answers? So the first thing we're going to do is rewrite our equation. So it's in y equals ax squared plus bx plus c. So we now can identify our our a is 1, our b is 0, and our c is 0. So our axis of symmetry is the equation x equals negative b over 2a. And so we just have to replace our a and b. So x equals negative 0 over 2 times 1. So x equals negative 0 over 2, which is just 0. So we know that the vertex is at 0. Now, these tables, for example, 1, 2, and 3, all have 4 coordinate points. The middle value I am always going to write as the vertex. So where that axis of symmetry is in the middle for the x value. Now let's find out what the y value is. Now our equation is y equals x squared. Instead of writing it as y equals x squared, I'm going to write it as a function notation, f of x equals x squared. You're going to do a lot more of this in Algebra 2, which is just really fun stuff with functions and transformations with functions. But for now, I just want to let you know we want to find the y value when x is 0. So we are replacing all of our x's with 0, and we find out that f of 0 is 0. So f of 0 just is a fancy way of saying that's our y value. So now, just to let you know, when we are finding our parabola, all of these are set up in this section so that the a value is either 1 or negative 1. So in Delta Math, you will be asked to find top 5 points. So that's what I'm going to do right now. The first thing you want to do is where's that first x value, meaning the vertex. Then we're going to go over to the right by 1 and left by 1. Then from that axis of symmetry, we're going to go over 2 and left 2. Now, we're going to plug in these numbers. So I'm going to go back to my red pen, red pen, and not sure why that's not picking that up. So f of 1 is 1 squared, which is 1. And negative 1 squared is also 1. It's always going to be symmetric. So the y values on either side of the vertex will be the same. And so now let's figure out what f of 2 is. And going back to our original equation, y equals 1x squared, or in other words, f of x equals x squared. 2 squared is 4. So those are our y values. So this is kind of fun stuff now. We're going to graph negative 2 comma 4 and 2 comma 4. We're going to graph negative 1 comma 1 and 1 comma 1. And then we're going to graph 0 comma 0. And with all of that, we're just now going to connect the points and in a parabola form. And that is our parabola. Now, that's all you have to do for homework, but this question says find the 0 or the solutions by graphing. So I want to make sure you understand that the solutions to this equation, or the zeros, or you can also call it the roots, are where the graph hits the x-axis, which is right here at the vertex. It's not always at the vertex, but that's when x is 0. That's your answer. But I want to just stop here and let you guys understand when your a value in the y equals ax squared plus bx plus c equals 0, when the a is 1, the shape of your graph will always be the same. Once you find the vertex, you're going to go over 1 and up 1. Then you're going to go from that vertex over 2 and then up 4. So that will always be the pattern when A is 1. That's what you're going to do for all of the problems in Delta Math, whether A is 1 or negative 1. So instead of showing all of this extra work, after you find your vertex, you only have to then use the pattern over 1 up 1 over 2 up 4. Or you can plug in numbers is fine. Now, I want to just have some fun with you guys. If you go to desmos.com, you can just press start graphing and then just go ahead and put in an equation. So I just wrote down y equals x squared, and you can just put x and then caret 2, enter, and you can see that if I put, and I put f of x equals, and I'm putting in f of x instead of y equals, is f of 0 equals, and it tells me what the y value is. If I want to find f of 1 equals, it'll give me 1. F of 2, enter. F of negative 2, enter. And f of whatever. It'll always give you your answers for y, which is a quicker way of doing it than using your scientific calculator, but something fun to think about. Now let's go to the next problem, and our next problem is our example 2. And our example 2 is just like the first review problem. The first review problem said solve by factoring. Here it says find the zeros or the solutions by graphing. So let's go ahead and use the steps that we learned about in the first example. So we're going to find our axis of symmetry. To use the axis of, or to find the axis of symmetry, use the formula x equals negative b over 2a. Identify what your A is 1, B is 2 in this case, and C is negative 3. So replace your B with 2 and your A with 1 in this problem. So x equals negative 2 over 2, which is just x equals negative 1. So we now know that our vertex will be in the middle of our parabola, and our x value is negative 1. Let's figure out what its y value is. So I'm going to rewrite the initial equation. Instead of y equals, I'm going to rewrite it as f of x equals using function notation. And we're going to put in and replace all of our x values with negative 1. Now note that I'm using parentheses. So now in your calculator, put in parentheses negative 1, close parentheses squared, plus 2, parentheses negative 1, close parentheses, minus 3, enter. You should get negative 4. So that is my vertex. Let's go ahead and plot that point. Negative 1, negative 4. Now, we know our A value is positive 1, so we are going to now graph it by starting at the vertex, go over 1 up 1, over 1 up 1, and then go back to your vertex and go over 2 up 1, 2, 3, 4. Go back to the vertex, over 2 to the left, up 1, 2, 3, 4. That's all you have to graph is just 5 points. That'll be delta math, and then connect them. Now, if you don't like that method of understanding the pattern of over 1 up 1 over 2 up 2 squared, meaning up 4, then you don't have to. You could just plug in. Now remember, when x is negative 1, you're going to go to the right by 1 and left by 1. And when x equals a negative 4, we're going to, or x equals negative 1, we're going to add 2, so that would be 1, and subtract 2. Those are your x values for the 5 points. And then we can just plug in, like for instance, what is the y value when x is 0? So f of 0 is 0 squared plus 2 times 0 minus 3, and that's negative 3. So you could just use your calculator or arithmetic if you don't like to think about the symmetric pattern of from that vertex over 1 up 1, over 2 up 4. And then also to find the y values of our next coordinate points, you can then just plug in f of 1, which is 1 squared plus 2 times 1 minus 3, and that is 0. And so those are actually our answers. So the solution to this problem is, I can say it's the zeros, or I can call it the roots or the solutions. And those are our x values when y is 0. So that was at x equals -3 and x equals 1. Now go back to the original problem on our notes, and those were the answers to the original problem. Now, I just want to show you with Desmos. In Desmos, let's go and type in f of x equals this equation. You can easily see that the zeros are -3 and 1 where it hits the x-axis, or you can actually put in f of, let's say, -1, enter, f of 0, enter, f of 1, enter. So you can always use Desmos to check your work, which is real fun to do. Okay, let's do the last problem. Hopefully you guys are getting a hang of this. First thing we're going to do is make sure it's in standard form, and then we're going to identify the A, the B, and the C. So A is -1, B is 8, and C is -12. We're going to use our formula of the axis of symmetry, and the axis of symmetry equation is x equals -b over 2a. So we have x equals -8 over 2 times -1, which is a -8 over -2, which is 4. So x equals 4. That will be at our vertex, so the middle of our parabola. So let's go ahead and figure out what the vertex y value is. So we'll rewrite our original equation. Instead of y equals f of x equals -x squared plus 8x minus 12. So f of 4 equals negative. Remember to put your parentheses when you're replacing your x. Put that in your calculator. -4 squared plus 8 times 4 minus 12. Enter. You should get 4. And so now I know that is my starting point. Now, because our A value is -1, that means that we are going to be going down now. So I'm going to go over 1, down 1, over 1, down 1 from the vertex. And then I'm going to go back to my vertex and go over 2, down 1, 2, 3, 4. Go back to my vertex, over 1, 2, down 1, 2, 3, 4. If you don't like that method, remember what you can do is say, okay, my x value is 4. And what we're going to do here is we're going to add 1 and subtract 1. Those are our x values. And then go back to that vertex x value of 4, add 2 and subtract 2. And then what you're going to do is use the equation. And to use the equation, you can say, well, f of 5 equals -5 squared plus 8 times 5 minus 12. Put that in your calculator, and you should get 3. And that's what we saw on the original graph anyways. And then you could do the same thing for 6 and f of 6, and you should get 0. So now we're going to connect those points. That's our graph. That's all you have to do in Delta Math, but here we're going to actually say what is our solution, or you can call what are the zeros, or you can say what are the roots of this parabola. All of that is just saying where does the parabola hit the x-axis, and it hits it at x equals 2 and x equals 6. If you go back to our review problem number 2, those were our answers to the same equation, but instead of solving by graphing like we're doing here, in the review we solved by factoring. Hopefully this was helpful for you guys, and don't forget to complete your Delta Math assignment for 9-2. Have a great time. If you guys have questions, send Miss Hazley an email or send me an email. We'll be happy to work with you. Have a great time doing this. Hope it goes really well for you guys.